Here.
Yeah,
Okay.
I started. Okay,
Fine.
Ali, please start.
Yes, Professor. Where am I? Yes. Okay. Okay, Professor. Today speak about gender classification methods. First, introduction. Gender classification is to determine a person's gender, male or female, based on his or her biometric case. Usually, facial images are used to extract features, and the classifier is applied to the extricate features to learn a gender recognizer. It is an active research topic in computer vision and biometric field. The gender classification result is often a binary value, 1 or 0, representing either male or female. Gender recognition is essentially a two-class classification problem, although other biometric traits could also be used for gender classification, such as gait, face-based approaches are still the most popular for gender discrimination. For human sex classification, usually the face image are used, although many other biometric case could be used too. So the study is mainly about how to extract features in face image so that the male and the female can be discriminated by using a classifier. As shown in figure 1, one can see the difference between a female and male, even though the facial appearance changes a lot with a gong in each row, like children or big. Now, gender classification approaches. Combinational gender classification is a standard pattern recognition problem. A typical framework is shown in figure 2. For an input face image, the first step is to the profound face detection. Then the detected face will be along elegant with other face based on the eyes coordinates. The purpose of alignment is to the correct some possible transformation such as translation relation rotation, and scaling and make all face have the same size. Facial features will then be extracted from the elegant face image. Classifiers can be trained using the extracted facial features and the corresponding gender label. It is a supervised learning process. Finally, the learned classification function can be used to recognize the gender for a last face image. This histogram or figures, face detection and face alignment and feature extraction and gender classification. Now, now we're talking about performance measure. The gender classification results are usually measured by the classification accuracy on test image. One can find the reported accuracies with different experimental step, like such as the number of face image in database, to the validation scheme, for example, five-fold cross validation. 3. The performance of gender classification can be measured by the confusion matrix with the contents true positive, true negative, false positive, and false negative result. Especially when the number of the females and males is very imbalanced. For based on the type of features used, geometry based on the appearance based. 5. The recognition of facial attributes based on gender, like happy, angry, sad, and neutral. Yes. Now, gender classification processing. Common to all gender classification methods is that each method take all the face sub image on input. However, the result depends on the methods and the details of the experiment. One, like neural network, basically before the face image and inputted to a neural network, there are some processing phases. Yes, the neural network is trained by giving it a female and male face example image as input. It is trained in rounds so that all examples are inputs to the one by one in around. The connection weights are changed after each image. When the image is input, the next time to the network, the output is closer to the expected output. The connection weights are changed using the back propagation algorithm. See figure 3. This for the illustration of how the output of the face detectors is converted to the input of the neural network. Yes, and now support vector machine. The idea of the SVM is that samples face images in the case of different classes, female, male, can be spirited in the higher dimensional space using the transformed features. And number 3, local binary patterns, LPPS, combined with SVM, a feature that is collocated from pixel intentions in a pixel neighborhood. The basic idea is that many binary values are created as there are pixels in the neighborhood of the center pixel. At the end, these are connected to a one binary value. And number 4, discrete adder-post. When a face image in classified the features values are collocated for the face image and age value is compared to the pane corresponding to the features and the value. If the pane contains more female features values collocated during training than male features values, then the classification result of the features is female and otherwise male. Now speak little about my workshop and UTK faces trying gender classification. For example, this and such as searching for the picture in which the features is wrong, like 25-2 or 10-2 pass. This number in age and this number in gender and this race. Basically gender 0 or 1, not 3 or 5, and maybe in picture inside the file using just 2 number, not 3. Rest lose. This code to search what is the wrong. I am using loop for I in range, and this code try image age gender race UTK accept or pass, and if result print UTK false. I forget this output. Okay, show later. Another example or where one of them was missed, like gender. This code line info equal 4, try age 0, gender 1, race 2, name gender file, age gender race image. This loop to explain about what miss it or lose, and this loop. Yes, and another example, implement image normalization from 0.255 minus 1. This image I am using norm image to zeros, image CV2 normalization image norm image 0.255 to change for -1. Yes, another solution. Get some statistical about the database. For example, how many females and males there are, how many females and males are from 20 to 15 years old. How many the number of the people of different race by race. Yes, I'm using this code explain quickly. I write genders, males and female, and I am using loop to explain this try image a gender race UTKI. If gender 0 quickly and 1, if gender 1 another. Yes, and this output we have we have men, we have men 17, female 18, right? Men 5, female 10, missed. Yes, and one using genders 3, 4, for I think race. No, 1, 4, 0, 3, 2. Yes, not sequence. Okay, and now this my workshop. Collocation, gender classification is an intersecting problem with many application. Significant progress has been made by research, and high courses can be optimal for gender recognition with the cooperative users in a constrained environment. However, it is still challenging for gender classification in concentrated environment with non-cooperative users, which prevails in many real application, including business, intelligence, or internet image analysis as a soft biometric trait. Gender recognition can help to improve biometric based human recognition. And this reference I am using 6. Yes. And end. Show my workshop.
Yes, yes.
Or later.
Maybe maybe now we listen Hoon, and after that we continue with Yoga Lab.
Okay.
Okay.
Okay, professor.
Hoon, please show your report.
Hello, Professor. Can you hear me?
Yes, yes.
I wanted to tell you this week I have no new result. I think I now I lack of some basic knowledge about the topic knowledge.
Okay, I understand.
I need time.
Sorry. What do you need? Please
because I video the lecture over again. I find some detail I don't understand. I need time to understand that.
Some details for understanding.
Okay. I think I think today we discuss that in our case. I think we should watch Ali collab. And after that, I think we discuss your questions. Okay?
Yeah. Okay. Thank you.
Okay, okay. Ali, please show your results.
Okay, Professor. Okay, now start. First of all, I am using my CPU for more speed, and first download this library, part 1 and part 2, and Makadir part 1 and part 2, and download and import this library. And now I want or solution save information about face in file name, age, gender, race. Professor, give me a good task and good code. I search and I read many lecture, and this solution start to know more about check attribute in info is correct. I am using this loop plain info equal for try a gender race and using name file a gender race GPG to know what to know where gender is missed. I am using this name of a missed first of all miss of missed 0 and miss 0, but this correct not filled, and to task change RGB in BGR. I am using OS path join pros path name CB2 CBT color image pros civil. Now save to BGR, and in this loop images return name of image means if we have is missed from gender. On this agreed part 1 and part processes, and using 64 change 32 on the 64, yes, and this name in M, N2, M2. Now print mission misses in the image. When okay, not that because not return. Yes, that is better. Now the Makadir. Save to image. This part. I don't know why download just 27, not all this file image.
Not all.
Yeah. Yes, not all, just 27%. And the stop.
Okay. Understand.
Yes, and the print is this number 2700 11 and 830 missed to lose. And now implement normalizing image in method getIm. I am using self transform equal transform and write file self file index on norm image about here we change X for matrix from 32 32 3 to 30 32 32 for result yes of PyTorch and implement image normalization from 0.255 to -1 1. I am using norm image. This norm image in zeros 800. Yes, 80
And why
0.
800? Why 800? You create norm image and p zeros 800 by 800.
I think give number big because more information, more resolution, like.
But okay, I will send you how we can
Yes.
how we can normalize image with easiest way. But of course
Yes,
you can
please.
use CV2 normalize. Okay, it can be.
Okay, and this function should return transfer from PyTorch. I am using this code. Image transfer self transfer image data is array image label and be array gender. Yes, and return tens for x long tens for y long. I think right. And other this code to methods, no change. This table already no change, and just this to I iter trained order, print the zero shape, torch size 3 40 64 and 64, and print the shape I shape, torch size like this, and this transpose to this main, and yes, and this code the same. Yes, now test for average and range, 1 in average plus 1, test this output, and using this size test lose it 51 or 51, because histogram error don't show me, and this histogram for this image. Oh, sorry.
Okay, Ali, may you send me your link, and we try
Yes.
to start.
Yes. Now. Okay, now.
Just check everything here. You can send in chat maybe.
Okay, in chat.
Mm-hmm. Okay. Can you see my screen yet?
Yes.
Okay, let's start. Maybe just look. Okay, GPU device is safe, and let's start. Connect. One moment. Connecting. So I think okay. So let's start. Oh, one is not password.
Yes.
Anyway. Okay. Now we are download.
Sorry, sir.
Places.
Repeater.
Hello. Yeah. Are you hear me?
Could you enlarge your screen?
No. One moment. Now is correct or not?
Enlarge your screen. Enlarge your word.
Oh.
Yes, we can see. Yes. Okay. Fine.
Okay, now we create folder, yeah, part 1 and part 2, where we will process our image. So let's let's try to save image, but guess that there is some problems here. Yeah, so try means we try to transpose str values, for instance 10, into integer, yeah, like this. So if we can't transform str into integer, so we will get error, and try just stop this block, stop running this block, and run the block in except, means this one. Yeah, means this one. For instance, the main problem will be here, because if you try to Control C, for instance, Control C here, yeah. If you try to integer this string, you will get error here, error. So we need to run this block in except, yeah. Of course, I guess that we can delete this one. I guess that we can delete this one, because we tried to read age, gender, and race, only 3 parameters.
Yes,
here.
excuse me, Professor.
Yeah.
Can you change? I have a copy.
Okay, just delete here, yeah, and we will use something like this, yeah. So we check that there is age, there is gender, there is race, and if everything is correct, we just num of image means that there is here you accumulate the number of correct image, yeah. Mass means that uncorrect image, yeah. Uncorrect image, maybe this, yeah, but except brick. Okay, I guess that everything is correct here, but this line maybe is not good, maybe doesn't need to stay this line. We just check that there is age, gender, and race, and after this we, if everything is correct, we create age, gender, race, accumulate number of correct image, and we start read image, change the color, and we determine we use detector for getting rectangles of faces on image. Yeah, LST means rectangles. If LST, sometimes LST can be empty. Yeah, it means that detector doesn't find any faces on image. So if LST is empty, so we just go to start another file. Yeah, go to start another file. If LST is not empty, we get the first face. First face means the first rect from LST, crop from image, and resize this image into image size. Where we determine image size in our class here. In our methods process data sets here. So we crop and resize using interlinear. After this, we change the CVCVT color. Everything is correct here. So and here you are return num of image. I guess that it is not correct because num of image and mass. Okay, maybe it is correct here, like this. Here we need to, sorry. I guess the print is not correct here, because return means we return the number of image and mass image of this function, yeah, and we can print these values because this values inside of function. So you get these values only here and here. Okay, let's try to run. Name is not defined. Okay, I understand. Name is your create name here. So and you use this name for saving, yeah, for saving. Okay, maybe it is a good way, because you just drop this part from your image. Yeah, okay, I understand. Nice. Drop the time from the name of image and save only gender, only age, gender, and race here. Yeah. Okay. Everything is correct. Let's try. So, and here there are a lot of time. Yeah, there are a lot of time for saving all image. Saving all image. Okay, let's see next. Now we need to create the UTK databases, and here we need maybe change this one. Okay, there are some simple way for normalize image. It means that you just get image and divided by 255. It means that if you divided your image, you will get normalized range. It means your range will be like this, from 0 to 1, because the maximum value of your image, it is 255. If you divide it by 255, you will get the range from 0 to 1. But of course, you can use this range. This range is better than this because you will have better convergency of your neural network. But the best range for convergency of neural network, it is from -1 to 1. So for this, you need to subtract half from here, and after this you can just multiply by 2, or maybe it will be more understandable if you divide it by the maximum value. It means that with subtracting you will get the range from -0.5, and when you divide it by the maximum value, it means that half here, you will get the range from -1 to 1, because you divided this minimum value by half here, and this value by half, and you will get the range between -1 and 1. Okay, what's happened here? Oh, I guess that there is some problem in process dataset. Some problem. There is some problem here. But what's happened? Why just 2708 file? Here we pass file lst. Something wrong here. So it is a max value between 0 and half, max value between 0 and left side, min value between image shape 1 and right. Something wrong here, but why we process only 2000 image, 3000 image. Okay. Which side? This brick is not good. It means that when you find the first not correct image, for example, the absent gender, you run this block, you calculate the number incorrect image, just one, and break the loop. But you need to continue your loop. You need to continue. It means that you don't want to run this code. It means that you don't want to read this image and transform your image into size 64 by 64. You just continue and start the loop again for the next image. Understand? Brick is not good for this because you just stop this loop and you will get only 2780 image only. So let's run again. One moment. Just you can see that when I restart after some problems, we will get such interesting error where you print each iteration in new string. It is not good for if you want to solve this problem. You need to restart. You need to restart all and run before and run here. Okay, we run process this dataset again, and now we can run this one, this cell, and so normalization. We write normalization here. Of course, you can use prepared function from OpenCV like normalize, but there are a lot of arguments on this function, and it is not good. Maybe it is more understandable when you just divide it by maximum value of your image, because it is a byte image. Subtract the half and divide it by half. So and after this you just get information about image shape, gender, and race, and image tensor transform. Okay. I'm not sure that you need to use this more. Okay, let's look. Oh, sorry. Let's comment it. Here we transform and image tensor image as array. I get that here we just need to use only a tensor like this tensor because we import tensor from PyTorch, and we can use just a tensor from image and tensor for okay, for gender, yeah, because we transform our string value into integer and we will get the value of gender, so just transform into tensor for PyTorch. Again, that here we need to use transformation into float using PyTorch methods like this. Okay, maybe now without, because if we get some errors, we just correct this one. So let's look what's happened with our data set. You can see that now we pre-process
Yes.
1000 image. Yeah. Okay. Maybe just wait. Yeah, just a bit wait. Okay, let's look other. Okay, now we can create train data and validation data from the our class of UTK data sets using preprocess path 1 and preprocess path 2. And here we, oh nice, yeah, it is a good way. So sometimes you can calculate, yeah, the value. I guess that it will be more clear if we just try to describe some layers here, yeah. So the size of image is 64 by 64, and after convolutional layers with kernel size 5, we will get the size of this image, sorry, equal 62 by 62. I guess that we will discuss it more accurate on my course in computer vision. So because we need to study in detail how the convolution layers work. So and now we just write the answers of each layer. If you use kernel size without paddings and without strides, you will get that the size of image will be decreased by 2. Sorry, not by 2. I guess that it will be 60 and 60 because 2 from the top, 2 pixels, 2 rows from the top, 2 rows from the bottom, and 2 from the left and 2 from the right. So you will get 60 by 60, and here after max pooling layer, we will get the image size reduced by 2, and it will be 30 by 30. So here we preprocess this picture 30 by 30, and the same things we use kernel size with 5, and we will get 26 by 26, and here we will get from 26. Okay. 13 and by 13, and here I just remind you that we will get 32 feature maps because these feature maps will be the same after max pooling layer, and the size of feature map 13 by 13, so we will need to transform these 32 maps with this size in linear layers. It means that we need to multiply 32 by 13 and by 13, and for example we want to get 50 neurons. It means that 50 features which will be combined in 50 features of image, and after 50 image, after 15 features we will get only 2 features. It means that 2 outputs, which mean gender here, gender. So, and methods forward just put your image through the all layers which we describe here in init. Means we put in convolutional layer. After convolutional layer we use max pooling layer and activation function relu. We discuss it in my course. So, and after this we do the same operation but with convolutional layer 2 and max pooling 2, and after this we transform our feature maps using view. Means we stay the same axis. Means, for example, our batch size is equal 16, batch size equal 16, so we stay this batch size the same, but we change other. It means, for instance, here our size is equal 32, 13 and 13, and after this transformation view we will stay the same 16. It means the batch size, but we change this free one. It means that we create such shape, 16 by this, and it is just a linear value. We just transform our feature maps into one-dimensional array here, and we use this one-dimensional array in classificator in fully connected layers, fully connected layer FC1, which we call fully connected layer with a linear linear layer here, and using the relu activation function. There is some dropout function, but sometimes we can use this or not for regularization. And return, it is the log softmax. It means that like a probability of gender for the image. So let's look second here. Okay, just the one data set. The process. Okay, let's discuss next. Here you should understand that when you change the size, you need to change something here, because each architecture of convolutional neural network depends from the size of image, and if you change the size of image, you should change the classificator of this convolutional neural network. For instance, when you transform your feature maps into one-dimensional array, you will change another one-dimensional array, and of course you need to calculate shapes through the all layers. For instance, when you use torch summary is important methods which show your architecture, your network using each layers here, yeah. And for example, you can determine some batch size and the size of image, and you will get information about all layers and how they change your image, your tensor through each layer here. Okay, so here everything is correct. Data loader. Here we just need to check the shape, the correct shape of data, input data and output data. Yeah? It is very important things. And here we just check that everything is correct when we transform our image into NumPy array. We need to change channels and here some comment, because now the shape of our image is 64 by 64, but the method PLT_show doesn't understand this one, this shape. For him it is not image. Image for its image is 64 by 3. Or it is RGB, RGB image. Or 64 by 64. It is a gray scale, yeah, gray scale. Scale image. If you try to use such one, you will get error, because for this method it is not grayscale image. You need to change this one to this one. Okay. So let's look again. Okay, maybe. Okay, we can stop now. We don't need to process all image. Now we just have 2000 images. 2000 images. Okay, let's look here. In N1. Okay, I stopped, and there is no any N1 and N2 variable. Okay, let's continue without them. So we initialize our class UTK datasets, initialize class of CNN model, import torch, initialize devices, CUDA 0, and now we can try to plot our model with this size, Okay, you can see that everything is correct. Output shape for each, linear layers. Okay, and here you can see the total parameters, trainable parameters, and the size of model. Yeah. We create train loader, test loader, run, and here, I forget if it's correct or not. Okay, let's try maybe. For input data is correct shape, but for output data just a 64. Let's try maybe. Let's try. Okay, this image. Okay, everything is correct. RGB components is correct here. Okay, let's continue. NP all we determine. Reinitialize our neural network. Initialized optimizer, which change weights from your CNN model. Initialize. We initiate train and test methods, and let's try to run. Okay, and something is wrong here. Something is wrong. Train f of 1. Train f of 1, but network train data, train loader, target. Okay, something target here, let's just flatten, but data float, data float, target, something wrong here. No. The main problem is that your neural network not trained, because 0 from 754, but test train f of 1, nothing happened. Batch ID train loader, network train, data, target, output, load record, next step. Print, train losses append, train counter append, train apple. Let's try to run just train apple here, for example 1. Train is the one. This is the message for loss of max. Test train target to device. Load. Okay. Let's try here maybe. Network to device. We will determine our iteration, and D is torch size. Okay, let's try to network, and we put into our network tensor D, and we will get flow tensors. Okay, here's some problems here. Torch flow tensors, CUDA flow tensors. So we need to put our tensors into device. So let's try. Okay, and we will get O. This is that. Let's look on the shape of O. Shape is 64 instances and 2 outputs for gender. And after this we can calculate the loss function. Let's try to calculate loss function, and we calculate O, and L means the label of gender here. So, and here there is some problem specs or type of CUDA target. Okay, we need to put device. Okay, and now we get loss. Okay, but the problem is that train loader, maybe some problems with the LAN, because everything is correct here. LAN, train loader, just 12. Why so? Train loader 12. How it can be? Train loader. What's happened? Just where optimizer step. Lock interval. Let's try maybe lock interval just to 1. Oh, okay. Everything is correct. It was my mistake. So let's try again. Lock interval will be equal to 3, and we try to train our neural network. Yeah, now everything is correct. You can see that we train our neural network and the accuracy is increased, the loss function decreased, but the main problem is that it is not enough for training. Yeah, it is not enough. We need to increase the learning step. Learning step in our neural network, for example 5, and let's change lock interval into 6, because it is necessary to see how neural networks train. Yeah, so now we can train better, but 50 Apple is not enough for training. Now we can plot the training. You can see that the loss function is decreased here, and training loss is escalate here, but test loss is decreased and accuracy increased. So let's try to get more Apple. For instance, okay, 500. And after training, we plot the train and validation curves. I guess that the home task for you will be change the model and try to solve the task of classification arrays, and you can try to solve age prediction using convolutional neural networks. I recommend you to change the model here. You can use more than 2 convolutional layers. You can get more than 1 and more pooling layers here. Yeah, it means that if you get more convolutional layers, you will get more high level features map, because using kernel 5 by 5 you have the receptive fields. It means that just a small window where you can see that this image 5 by 5 you can see only 5 by 5 only 7 by 7. It means because 5 overlay by 5 you will get only 7 kernel size, and this task can be not solved using these convolutional layers. I guess that you need to more than one. You can apply the third or the fourth layers, and you will get how they change your curves, train and validation curves. What's happened here? X and Y must be the same size. That's close. So, and here you can see that there are a lot of overfitting, yeah, because our validation or test flows decrease, and after some points, after this iteration, the loss will be higher, yeah, but the train loss is less. It means that this part of training was overfitting trainings, and you can see that we could solve this task for training data sets, but we worst solve this task for test data. So I guess that the home task will be improve your model, just add some convolutional layers. Yeah, you need just add convolutional layers. I guess that maybe convolutional layer 3 and 4, and you should change linear layers when you add some additional layers. It means convolutional with max pooling, because it is one block here. Yeah, block 1, block 2. It is a pair layer here. Yeah, you can add some layers here and here. For example, you add the third layer and try to train your model, and you can add additional the fourth layer and again train your model and see what's happened. It is just a scientific task. Yeah, just scientific task. You try to understand what's happened if you add some convolutional layer. And of course, it will be best if you try to train your model for race classification and age classification. But for age, you need to process the age because of age is changed from 0 to 160. Yeah. So I recommend you to preprocess. It means that you need to preprocess something here, where you will get age, from 0 to 116. You need to preprocess something like this. For example, 0, it will be young, maybe, yeah, young people, yeah, young. For example, from 0 to, okay, maybe let's 16, for example, yeah. The second class will be 1. It is, for example, age from 16 to okay, to 30, and etc. Maybe some 9 class. For instance, from 70 to something like this. I just recommend you to experiment. Yeah, you need to for the first time you can split this range, for example, for 3 groups for free classes, try to train your model, but for the second time you can change the age for more classes, maybe for 9 or for 10 classes, and train your model to classificate age class, yeah, age class, for example, 0, 1, and etc. Yeah, here you need to determine, yeah, the group, but of course, youngest group is difficult. I guess that you need to change from 0 to 3, and maybe here the second group will be from 6, or sorry, from 3 to 5, and etc. Because people faces change faster when you're young, yeah, and they can be changed better. But of course, you can determine like from 0 to 15, it's just a child, yeah, and etc. So, but of course, it is like an experiment, and try to solve this task. Maybe after the next lecture, I will get you the complicated task when you can try to use one neural network for all tasks. It means that you can use only one neural network which will be predict age, gender, and race. It is more complicated task because you use all information and you change the weights of your model using loss from race, from gender, and from age. It will be an interesting task because you can use only one neural network for all. But of course, the accuracy will be worse than you use only one task. Yeah, when you solve only one task, for example, gender or race. Of course, neural networks solve this task better when this one solving all of them. Yeah. So I hope that maybe some questions about this. Or no?
Yes, Professor. I don't have a question now because more information. I read and record the lecture. And please, I needed I needed information for this material, like link or anything.
Okay, maybe I can share. Yeah, share this one. Here I will change something. Yeah, I guess that you can understand what's copy. Anyone get link? Copy link. I send this link here. Yeah. Sharing. You can see. You don't have permission to save this node.
You need to save a copy and drive.
Okay, one moment. Save. Loading. And I can share the copy link.
No, change to any with the link.
I guess it's one. Okay, try to open. I send in chat. this is the same task. I mean that now you can solve the task for gender classification, and of course
No open, Professor.
no open. One moment.
Yes, because no change copy.
Okay, copy, save. File, save.
No, just again share. Again share.
Okay, one moment. This one or not? I guess no. What? Save. Okay, share. Change to
Yes.
that one. Ah, okay, I understand. Thank you, Ali.
Welcome.
It tried to open. I hope that everything is correct. So it should be noted, and always you need to check that everything is correct using curve. Curve, it is important things for neural networks. You can't see what's happened in neural networks, but you can always see on curves of training curves and validation curves. Your training curves should be decreased always, yeah. And if you, okay, maybe I will show. No, I can show.
Sorry.
If you
no
yeah.
open this link.
What's happened? Share. Anyone can view.
No. This
This one.
is now change to anyone.
Change to anyone. Viewer. Anyone with the link. Anyone who can edit. Done. Okay, maybe try again.
Yes, change. No, change. When the link green.
When, okay, let's try.
Green, yes, correct.
Okay, send in chat again. The last one. 1KJK. Okay. I need to delete previous one.
Yes, open.
And delete this one. I can relax. Okay, so you can open. So the main idea that you should use training curves always. If your training curves is decreased, train loss decreased, it means that everything is correct. Your neural network is trained. Of course, you need to look at test loss or validation loss, and this loss should be decreased too. But of course, there is some problems when your validation loss is increased. Yeah, for example, here decreased and here is increased. Yeah. It is a problem of overfitting your neural network. It means that your neural network is not good. So try to input some additional layers. I guess that I rewrite this notebook a bit for you because I don't like such data interpretation like this. It is not a good way because you can see everything here. Yeah, it is very difficult to see what's happened because here is a train path and test path. It is not good. So I just maybe rewrite for the next lecture. So your task will be train classificator for phrase. Okay.
Okay, okay, Professor. Now I needed some material about this.
Okay.
Anything.
Try to find it and send in our keys.
Yes.
Maybe
And
some useful links.
yes, and need if you can write what I do next lecture.
Okay. Okay. But for today, your work is best. is best.
Okay, okay. Thank you very much, Vasily. Thank you very much, Ali. And the second question is questions from Hun. Hun, can you show your screen and your questions, please?
Professor, thank you. I just can't do something about the task. I
Okay.
think I need to watch the lecture video over again.
Okay, understand. I hope you can do it to next lesson. Okay.
And if you have any question, just write, and we discuss it on the next lecture. Yeah.
Yes, you should do something to each week. It is really important work in plan. Okay.
I guess that you can send email for Ali and ask him because.
Yeah, Ali is the best. Okay. And if you don't have any questions, I think all for today.
No. I will try to complete my task.
Okay.
Okay.
And I think we see you next week.
Thank you very much. See you.
Thank you, Professor.
Okay.
Goodbye.
Goodbye. Thank you.
Goodbye, Professor.
Bye.